Hello, in this video, let's look at the chain rule. Chain rule is used when we take a derivative of some function that is a nested function. So it's a composition of functions. In other words, we have two functions, f of x, and inside of it is a different function, g of x. And we're trying to take a derivative of that whole composition. And so we have the outside function and the inside function. And the chain rule says that first we take a derivative of the outside function and just leaving the inside as it is, then times by the derivative of the inside function, which is the g. So here's an example. We have 3x squared plus 5, the whole quantity squared. So on the outside looks like something, so here's the outside, is something, this is the inside, this is the outside. The outside is some kind of thing squared. And how do we take a derivative of something squared? Well, here on the side, if I had just a letter x squared, what rule would I use? Well, that would be power rule. And the answer to that question would be 2 times x to the power 1 less than the original, which is 1. So the same rule applies here. The derivative would be of the outside is going to be equal to 2 times whatever that inside is to the first. And we just copy in what that inside function looks like. So that's the derivative of the outside. Now times by the derivative of the inside function, and the inside function is this g function, which is 3x squared plus 5. So we also multiply by the derivative, of the 3x squared plus 5, which of course is just 6x, because the derivative of 5 is 0. And so our answer would be 2 times 3x squared plus 5, and then times 6x. We could also multiply this out and simplify if we wanted to, and that would be 12. 2 times 6 is 12x times 3x squared plus 5, and if we distribute further, we would have 36x to the third plus 12 times 5 is 60x, and that's the final answer. Now, at this point, we might be asking ourselves, why did we bother with this anyway? Because we know how to square. We could have just as easily applied the formula for the perfect squares and expanded it out, and then took a derivative of each term separately, and we would get exactly the same result. But there are other situations where that is not practical. So here is a different example. It's a similar example. We have the inside function, and the outside function is to the 10th power. At this point, multiplying out or foiling this expression 9 times does not make any sense, any practical sense at least. So the chain rule is the by far the most efficient way of taking the derivative. And so let's use this formula once again. The outside appears to be something to the 10th power, so it's like x to the 10th. What's the derivative of something to the 10th? Well, that would be 10 of that something to the 9th. And that's exactly what the derivative of the outside function would be. It would be 10 of that inside to the power 9. And the inside function is unchanged, which is x squared plus 5x plus 1 times. Now here we have times the derivative of the inside function, so times by the derivative of x squared plus 5x plus 1. And what is that derivative? Well, the derivative of x squared is 2x, the derivative of 5x is 5, and so once we copy over what we had in the front, we would be done. So that's 10x squared plus 5x plus 1 to the 9th times by 2x plus 5. And that is it. That's how to take a derivative of a composition of functions using the chain rule. And that's all there is for the chain rule. If you have any questions on anything, please let me know. Thank you for your time.